All right, now I'm going to review definite integrals with u sub. We are going to continue our work with u subbing on integrating, just like we did with indefinite integrals. Sometimes we need to play around and change the limits, which I'll show you with, like I did in class, which I'll show you with some of them. And sometimes we need to just play with the u sub, and anyway, I'll find some complicated ones to do together. So let me grab an example that we didn't do in class. Okay, I'm going to go ahead and do number 4 on the next page. All right, so we've got the integral from 0 to square root of 5 of x over the square root of x squared plus 4 dx. I'm going to go ahead and try and make u equal to x squared plus 4, which gives me du as 2x dx. It looks like we have the x. We need the 2. We also have the dx. Okay, we need the 2, so when we change this into du, it is going to have a 2 in it, so we have to multiply by 1/2. So that's going to be 1/2 the integral from 0 to square root of 5 of what? Of u to the negative 1/2 du. All right, there's our u to the negative 1/2. Du is 2x dx, and here's the 1/2, and we are ready to integrate. We can change the bounds if we want, and rewrite this and integrate it from, let me see, let's integrate it from u is equal to x squared plus 4. So we can change the bounds and integrate. Instead of 0, it's 0 squared plus 4, so that'll be from 4 to square root of 5 squared plus 4, so from 4 to 9 of u to the negative 1/2 du. Now we could do that. We can do that. And then we can go ahead and take the integral, so u to the negative 1/2 plus 1 over negative 1/2 plus 1, which gives us u to the 1/2 over 1/2, so multiplied by 2, and multiplied by that 1/2 that's already there. All right, so the integral of u to the negative 1/2 is 2 u to the 1/2, because it's u to the 1/2 over 1/2, 2 u to the 1/2, multiplied by that 1/2. So that's u to the 1/2, and that's going to be evaluated at 4 and at 9. So we're going to do the square root of 9 minus the square root of 4, so f of b minus f of a, which gives us 3 minus 2, which gives us 1. Now, what if we didn't change the bounds? What if we didn't do all of that changing of the bounds? That's okay. So let's take 1/2. The integral of u to the negative 1/2, which we already did, is 2 u to the 1/2, multiplies by that 1/2, so it's just the square root of u. That's going to be evaluated at 0 and at radical 5. Okay, so it's the same thing. The only difference is, since I didn't change the bounds over here, I just need to put, after I integrate, I just need to put u back in and then operate on my x's instead of my u's. So square root of 5 squared is 5 plus 4 is 9, gets you the square root of 9. Square root of 0 plus 4 is the square root of 4. So it's the same thing. It's the same thing. Okay, you can do it the same way and put the u in and then work with the x's that you've got, or you can take the extra step and change the bounds and sub into the u. It's going to give you the same thing. So let's take a look at 6. All right, in 6 we are integrating from 0 to pi over 6 of 1 plus sine x times cosine x. So the integral of a sum is the sum of the integrals. So let's split this. The integral of 1 dx plus the integral of sine x cosine x dx. Okay, and this right here, the derivative, a function whose derivative is 1 is x, and we're going to evaluate that at 0 and at pi over 6. So f of pi over 6 is simply pi over 6, and f of 0 is simply 0. So when we're ready, this guy right here, area under the curve is pi over 6. We're going to add that 2. Okay, now we're going to work on this guy over here. So again, the integral of 1 is x, And we're evaluating it at pi over 6 minus evaluating it at 0 to get pi over 6. Now sine x cosine x is a u sub. I'm going to set u to be, I don't know, let's set it to be cosine x dx, and du is negative sine x. Oh, it's not cosine x dx. It's just cosine x. And du is negative sine x dx. All right, so it looks like I've got du, except I need to multiply by a negative. I'm not going to change the bounds on this one. I'm just going to keep it. So we've got minus the integral from 0 to pi over 6 of u du. Here's my u, cosine x. My du, which is sine x dx. Boom, boom. There it is. And there's the negative that we needed to account for. The integral of u is u squared over 2, which means it's cosine, oh, let me not write it there because that's my answer. I'll just do it kind of like over here. Integral of u is u squared over 2, which means it's cosine x squared over 2 evaluated at pi over 6 minus evaluated at 0. So cosine of pi over 6, and you could change the bounds if you want. Cosine of pi over 6, that's cosine of 30, which is square root of 3 over 2. Square root of 3 over 2. And if we square that, that's 3 over 4 divided by 2. So 3 over 8. Minus cosine of 0, which is 1/2. Right? Okay? And then if I actually like do the math here, I get 3/8 minus 4/8, which is negative 1/8. Multiplied by that negative gets me positive 1/8. So this was going to be negative 1/8. Multiply by the negative that's there to get positive 1/8, and that's the final answer. Okay, let's take a look here. If the integral from 0 to 1 of f of x dx is 6 and 4 and negative 8, let's find the following. Okay, the integral from 0 to 2 of f of 2x dx. Since it's not f of x, we do need to do a u sub. We're going to set u equal to 2x. Therefore, du is 2 dx. So we need to multiply by 1/2 since we have the dx, but we don't have a 2 constant coefficient. So this is 1/2 the integral from 0 to 2 of f of u du. All right. I'm going to go ahead and change the bounds on this because whose function makes f of u? I don't know. So let's change the bounds. If u is equal to 2x, then when x is 0, u is also 0. And when x is 2, u is 4. And I was using this u sub. So I want to change it from x bounds into u bounds. And x times 2 is u. So change my 0 into 0, change my 2 into 4, make it a u problem. It's a u problem. And we were given this right here. Therefore, 1/2 times negative 8 is the final area under the curve of f of 2x dx under the following conditions, of course. So let's take a look at number 9. We have to set u equal to 1/2 dx, 1/2 x, sorry. Du therefore is 1/2 dx. I'm going to go ahead and change the bounds too while I'm at it. 0 is still 0. 2 for x will make a u of 1. My du is 1/2, so that means I need to multiply by 2. Just make sure that's right. My du is 1/2. I don't have a 1/2, so I need to multiply by 2 to make sure that my du times my 2 is a value of 1. Was I given the integral from 0 to 1? I was. I have that answer, 6 times 2, therefore 12. So try 10 and see if you get an answer of -6.